So in previous class, we have done justice to what container is, what images are. We have also looked at container registry. We we did a case scenario where we actually create our image and then push to a container registry. So you can find links to all the videos in the description of this video. But in today's class, we'll do justice to what Docker volume is. We'll explore what Docker volume is. We'll also use MySQL database as a case study to give us a better understanding of what Docker volume is. What exactly is Docker volume? So Docker volumes are persistent data stores for containers. They are created and managed by Docker. So they provide a reliable and efficient way to ensure data persistence when working with containers. So by default, Docker containers are ephemeral. And by ephemeral, I mean that they are temporary and stateless. So any changes you are making inside a running container, such as adding files, installing softwares, or modifying data, these changes will be lost once the container is removed. So this approach works very well for stateless application, but it becomes a problem for containers that need to retain state. Example is database such as MySQL, Postgres, or MongoDB. So in containers that need to retain state like MySQL, you want to ensure that when the containers are destroyed, when the containers are destroyed, that you still persist this data that are stored in these containers. So to solve this problem, Docker volume is the solution. So Docker volume solves this problem by allowing you to store the data outside the container file system in a persistent and reusable location. So what Docker volume does is that these files or data that are stored in these containers are being stored outside the container file system. Now we'll understand better. So there are two types of Docker volumes. The first is a named volume. So these named volumes are created and managed by Docker. They are not tied to any specific location on your host. So what that means is that when Docker first of all store this data or file or whatever you want to persist in a particular location, which is variable /var/lib /docker/volumes, and then the name of the volume. So every name volume is stored in this directory, and they are fully managed by Docker. So the structures are fully managed by Docker. So your host machine or your OS machine do not have a modification right to that directory. So therefore they are best suited for database and production data. So they are portable across environment. So why this is physically important is that name volumes are saved from accidental modification by the host operating system or by the user itself. So they can work on any operating system such as Windows, Mac, Linux without any issue. So the second type of volume are called the bind volumes. In bind volume, you use a specific directory on your host machine. It can be any directory on your host machine, and then you map it to the directory on your container where you want to persist data. So what it basically means is that you have a direct link between a folder on your host machine, laptop or PC, to a directly on your container. So this directory can be modified by the user, it can be modified by the operating system. And so they are good specifically for development where you want hot reload. So they are not recommended for productions. So We're going to look at some of the Docker volume commands. How do you create volumes? How do you list volumes? How do you inspect volumes? How do you rename volumes? And then we'll go further to look at the case study of MySQL, which is a database. Um, so let me run you through the commands. So I have my Docker desktop running first of all. So make sure your Docker desktop is running on your machine, right? So I'm using a Windows machine. So for Windows system, use a Windows Docker desktop. You can find that in our previous tutorials. So open the command prompt. Now what I want to do, I want to create volume, I want to list volume and remove volume. So first of all, let's see the volumes currently on our machine. So if I so the command is docker and then volume. So you can have your options and then your command, just like we have seen in our previous lessons. So docker volume ls is going to list all the volumes currently on my system, right? All the volumes on my system. So you can see currently we have three named volumes. So the first is this, the second one is minikube, and the third is MySQL volume, which are named volumes. So so to create a volume, use docker volume and then create. So you what name do you want to give the volume? So let's say you want to give the volume um, data persists. After it's a good practice to always give a volume in a name that makes more meaning and directly relates to whatever you want to use that volume for. But I'm just using this as an example. So as soon as you do that, you have a volume created. So if I go back to see all the volumes currently, so docker volume ls, I will see that volume currently have been created on my on my machine. So you can also delete that volume. I'll use docker volume rm for remove and the name of the volume. So if I go back and do docker volume ls, I will see that that volume have been deleted or removed. So you can see this type of volume are named volumes. Physically, they have a name. So you've created a volume and given them a name, right? So look at when we start working on some of our lab, we'll look at bind volumes. And bind volumes, those volumes you are physically not giving them. You're just mapping um, a directory on your container to a directory on your host machine. For name volume, you create a volume and give it a name, and Docker manages that volume for you. So for the sake of our lab, we want to create a MySQL container and then map and create a volume, persist data on that MySQL using volumes. So let us create a volume for our MySQL container. So I'll do docker volume create. Um, I'll give the volume MySQL for HEMR, right? So docker volume create. If I say docker volume ls, you can see that volume will be created for us, right? So with this volume created, we'll create a MySQL container and then map that volume to our container, right? So before then, let's go to Docker Hub, right? And then let's look for the MySQL official image. I'm going to search on Docker Hub for MySQL, right? And then, so you can read through their documentation on how you create your containers, right? You can read through their documentation how you create your containers. So if you read through this their documentation, you can see that to create a Docker container, you use Docker run, as we've discussed this in our previous lesson, and then MySQL, and then the tag, right? You can see various tags here on on um, on the documentation. Now, very importantly, when you create MySQL container, it creates a root user by default, and so you use from the documentation you are going to use environmental variables, which is -e, to create we're going to create an environmental variables MySQL root underscore password and then assign a value to that environmental variable. That password will be used as password for our root user, right? So, but before we jump into this, it's very important for you to understand this. Now, MySQL stores all its database file in this directory /var/lib/MySQL. So every data you store, if you do your create user, if you create user, whether you're creating the data, whether you're updating the data at MySQL, all those data are stored in for Linux are stored in this directory var/lib/MySQL. So what it means is that this is this directory on our container we want to persist, right? So because all the data are stored here, so this is what we want to persist. Very important. So this is the directory we're going to map to whatever volume we want to map to, whether it's a name volume or a bind volume. So if you delete the container, all databases are lost except you use a volume to map this particular directory, which is var lib MySQL. Let's take note of that. So let's go back to our command prompt. So we have to run a container, we say docker run and then MySQL. That's the name of the image. Now optionally you can choose a tag. I'm going to use 8.0. Right? So this is by default this is the command to actually run MySQL container. Now between the run and your image, you have options. You can put your options here. Compulsorily, when this container is created, a root user is created for us. So use environmental variable to actually create an environmental variable, and that environmental variable, the value of that environmental variable is given to the user as password. Is bind to the user as password, and so we create a environmental variable which is this, right? So I'm going to copy this. We'll say equal to secret. So what we are doing here is that we're creating an environmental variable with a value secret. Now this particular environmental variable will be used as a password for our root user. Very important. We also want to give this a name. So I will name MySQL, I will name it anything, or can name it let's say volume lesson. Volume lesson, just for the sake of this class. We have to use a meaningful name as we discussed in our previous class. Volume lesson. Now, which other option do we need to have? -G on the background. Now, port mapping. By default, MySQL works on port 3306. That's the default port for MySQL. But I want to map it to a different port on my computer, right? So I'm going to map it to 33, let's say 3316. So what we are doing is that we're mapping port 3306 on the container to 3316 on our host machine. So when you want to, when the request come through this port on a host machine, it's redirected to this port on the container. That's what it means, right? Okay. So lastly, this by default, this is okay to create a MySQL container, right? But beyond that, I want to persist the volume, right? And so to persist the volume, we use -v command. And then we want to map. Remember that we created this volume in the former class. So remember that we've created this volume, right? So this volume that we created, I want to map this volume. I want to map it, right? Just the way we map ports. I want to map this volume to this directory on our container. We are mapping to this directory on the container because this directory is where all data, whether you are creating a record, whether you are creating a user, creating a table, everything is stored in this directory. So this directory houses all the data stored in MySQL, and that's why I'm mapping it to this volume to persist it. So as soon as you do that, you press enter. So our Docker container has been created. So if I do Docker container ls, this volume, you can see we have it created. Now, one more thing I forgot is that we touched on how to create a volume, how to remove a volume, how to list a volume. Let's even look at how to inspect a volume. So if I take this volume and do Docker inspect, it gives me information about that volume. You can see the date the volume was created. Importantly, this is, you can see where the volume is mounted on our host machine. Like I told you before, docker lib, docker variable lib, docker volume, the name of the volume, MySQL. So this is, and this particular directory, like we said, is a name volume. It's managed by Docker itself. So very importantly, I have to call your attention to this because we didn't explore Docker inspect, right? So Docker container ls. So we have created this container, which is MySQL, and then we mount this volume on this container. We map the /var/lib/MySQL, which is the directory where all data are stored in MySQL. We mount it on this container. Now we map port 3316 on our host machine to 3306 on the container, right? So we are going to connect to this container and then create some record, delete this container, recreate it, and verify that the data we created persisted. Okay, so to manage our MySQL database, I'll be using MySQL Workbench, right? The other tools you can use, you can even use your command line tool, but I'll be using MySQL Workbench. MySQL Workbench is a GUI, is a recommended or approved GUI graphical user interface for managing your MySQL. So I'll go if you don't have it, you can go to the official page and download it. All you need to do is I'll go to Google and say MySQL Workbench, right? Go to the official website. And then you can download it, right? But I have it already installed on my system. So all I need to do is to look for MySQL Workbench, right? And then have it open. So I'll create a connection. I'm going to give my connection a name. Let me call it volume lesson, right? So remember that on our host machine, what we mapped 3316 on our host machine. So we are connecting to Docker MySQL container through our host machine, and then root. So let's first test the connection, and then we have a password. Our password was secret. So we test it. It's successful. So the connection was successful. So I'll just connect to our database. So this time, okay. So you see, we have this volume, we have this connection saved. So to connect to it, all I need to do is to click on this, right? So we have our, we have connected to our database, to our SQL, which we just created using port 3316. So I'm going to run through some of the. So let's do some let's write some queries. So first, I have these queries. I have some saved already. I'm going to run through these queries, right? This first query is to check the version of MySQL you have currently. So I'm going to copy it, run it here, run this query. So it gives you the version which is 8.0.44, right? So the first thing I will do is to create a database. So, or let's even show, let's create a database first. Before then, let's show our database we have. So I'll paste this here. So the command is show database, right? So I'll run this. Currently, it's a database by default that came with MySQL, right? So, but we're going to create our database using create database and then the name of the database. So, create database. We are creating a database called this, right? My test, my DB. So, to highlight and run it. So successfully created a database. So if I highlight this now, show database and run, you see we have the database created. So fourthly, let's create a table on this our database, right? So first of all, we have to go into that database which we just created by using use and the database we want to work with. So that ran successful. So so the next is to create a table. So I'm going to copy this command. So we're creating a table called users, right? We're creating a table called users. So you can see it, create table users, and the fields ID. Okay, ID is an integer, auto increment, it's also a primary key. Created another column called name, which is a varchar with 100, with length 100, email. So I'm going to execute this. We have our table created. You can, let me refresh this. You can see our database created. If I list, you can see this table. You can also, I can run in the GUI. Let's see what is in that table. Currently, we have 1, 2, 3, 4. These 4 columns. Remember that if you go to our command the way we created, you can see that our our ID is the primary key, right? So now I want to add some things to this. Add some values to this column, right? Let's create a record on that database. So I'll go back to my first query here and under here. So to do that, we use the insert into, right? So insert into users into a name and email column, or inserting Alice and then Alice example.com. So I'll do this and then run it. So if I run this other script here, you can see we have Alice this created. So I can add more records. This time I'm going to change to volume. The name will be volume and email will be volume at example.com. So if I highlight these scripts, and then run, see we've created, the query was successful. If I return back to our scripts and select all, run the scripts, so we have these two. So currently we have a database, MySQL database with records created on that database, right? So now what we're going to do now is to delete this container, recreate it, and confirm that this volume, this data was not deleted with the container. Let's even delete this volume. Let's delete this connection. So I'm going to delete connection, right? Okay, so I'll return back to this. And let's see our container, Azure container. Yes. So let's assume for some reason or whatever reason, we have our container deleted. And I'll delete the container. Let's stop the container first. So Docker container ls. So our container has been deleted. If I return back to try to create a connection, let's see volume, right? Volume lesson. Let's call it volume lesson. And then it was in port 3316 test. So that we don't have that container again. Now, it's a, normally our data would have been deleted with that container. So what I will do, I'll try recreating on that container. Let's return back to the command. So this time I'm going to call this volume 2. Now, I'll map it to port 17. Now, you can see the same volume. So this volume now is not empty. This volume is not empty. This volume contains the previous data from the deleted container because it was mapped on that container. So now I want to create a new container mounting the same volume on that container. Therefore, the data persisted on this volume will be mounted on the new container. So if I do this, I say container, Docker container ls. We have our container, which is on port, mapped on port 3317. If I return back to our SQL and change this to 17 and say test, you can see we have a test. So let's even log into our container. Let's log into our volume secrets. So we have a new container. As you can see, the database on that volume still persists. So data still persists. If you go to our table and view, you can see those data is still there. So what we have done is that we've deleted the old container, created a new container, and mount the same volume which was used to map on the container. We mount it on this new container. In that way, even though our container is deleted, our previous data persists, and the volume is mounted on this our new container. We still have our data back, right? So, in summary, Docker containers are ephemeral. When you remove a container or delete a container, whatever you store on that container gets deleted with it or gets removed. Now, to persist data on that container, we use Docker volume. And what we have just done is that we have used MySQL as a case study. We've created a container, a MySQL container, and then write data to that container, deleted the container, create a new container, and mount that same volume on the new container, and we have seen that our data persisted, right? So this, in summary, is the primary responsibility of a Docker volume. So this type of volume we created and then mount on our container is a named volume. It's being managed by Docker. We have no permission to modify anything on that directly being mapped on the host machine. Now for bind volume, if you look at the command for bind volume, rather than using a named volume that was created, we are going to map this directory on the container I want to persist to a directory on our host machine, right? Or to directly on our host machine. Let's say um, let's say slash this, right? Slash options or whatever, just any directory on our host machine. So in this case, the data on the container will be mapped to a directory on the host machine. And that directory can be edited by the user, it can be modified by the operating system. And so you may have issue of accidental deletion, accidental modification, which can affect the volume. And that's why it is said that a bind volume is not recommended for production data. So for production data, name volume is recommended because that volume is the name volume, the location of the name volume, which is managed by Docker, is isolated from the host machine and um, and then is being guided against modification by the host user, by the user host operating system. So we're going to have preventing issues of accidental deletion or modification, right?